We learned that carbon atoms can be linked together to form chains of varying lengths. These chains can be branched also. In addition, hydrogen atoms or other atoms on this carbon chain can be replaced by any of the functional groups. The presence of a functional group such as alcohol decides the properties of the carbon compound regardless of the length of the carbon chain. For example, the chemical properties of CH3OH, C2H5OH, C3H7OH and C4H9OH are all very similar. Hence, such a series of compounds in which the same functional group substitutes for hydrogen in a carbon chain is called a homologous series. In a series of compounds in which the same functional group substitutes for the hydrogen in a carbon chain is called a homologous series. Here you can see that CH3OH and C2H5OH. The difference between these two, here we can see that in the second case C2H5OH, here one more carbon and two more hydrogen atoms are there when we compare it with CH3OH. Like that, C2H5OH and C3H7OH, here the functional groups are same in all these cases. That's why we are not considering it when we consider C2H5 and C3H7. In C3H7, one more carbon atom and two more hydrogen atoms are there in addition to C2H5. Like that, in C4H9, when comparing it with C3H7, in C4H9, one more carbon and two more hydrogen atoms are there. Then what is the difference between the next pair? Okay, the difference between each pair is here one carbon atom and two hydrogen atoms. They have same general formula. For example, we learned that for alkanes, the general formula is CnH2n plus 2, and for alkenes it is CnH2n, and for alkynes it is CnH2n minus 2. They have general formula, same general formula and have same chemical properties but show gradual change in physical properties. Once again, homologous series is a series of compounds in which the same functional group substitutes for the hydrogen in a carbon chain. Here we know that the difference between the two compounds in a homologous series is that is they differ by CH2 group, one carbon and two hydrogen atoms. We can say that in a homologous series, two compounds differ by CH2 group. You have already learned in your 9th standard that the atomic mass of carbon is 12 atomic mass unit or 12 unit, 12U, and the atomic mass of hydrogen is 1U. Any two homologues differ by CH2 group, and the difference in molecular mass is C, carbon, the atomic mass of carbon is 12 plus 1 into 2, that is 2 hydrogen atoms are there, or we can write 1 plus 1 for 2 hydrogen atoms. Then what is the difference in molecular mass? That is 14U. Any two homologues differ by CH2 group. Any two compounds in a homologous series differ by CH2 group, and the difference in their molecular mass is 14U. Here you can see the alkanes. Here it's a homologous series. You can see first it is methane. Its molecular formula is CH4. When we add CH2 group to it, we will get C2H6, that is ethane. When we add CH2 group to it, we will get propane, that is C3H8. When we add CH2 to propane, we will get butane, that is C4H10. When we add CH2 to butane, then we will get pentane, C5H12. Like that, when we add CH2 group to pentane, we will get hexane with molecular formula C6H12. It is a homologous series of alkanes. Here, these follow one same general formula. Here they differ by only CH2 group, and the difference in their molecular mass, we have learned here that difference in molecular mass in a homologous series is 14U. Homologous series. The series in which the compound with the same general formula but different molecular formula occur in immediate succession. Series in which the compounds with the same molecular formula but same general formula but different molecular formula occur in immediate succession. Series in which the compound with same general formula but different molecular formula occur in immediate succession. Here we have already learned it. It's a homologous series of alkynes. Here you can see that all these methane, ethane, propane, butane, pentane and hexane all have same general formula because they all are alkanes. Their general formula is CnH2n plus 2. But they differ by their molecular formula. The difference is in their molecular formula. The chemical properties are similar. For a homologous series, the compounds, their chemical properties are similar, but their physical properties are different. Their physical properties are different. The physical properties such as boiling point, melting point, solubility. In all these cases, they will show difference. The boiling point of homologous series, when we consider or when we observe the boiling point of homologous series, we can see that a compound with 10 carbon atoms will have a high boiling point compared with a compound with 3 carbon atoms. A compound with 10 carbon atoms will have a high boiling point compared with a compound with 3 carbon atoms. That's because the energy required to break the bond will be greater. In the case of a compound with 10 carbon atoms, the energy required to break the bond will be greater when comparing to a compound with 3 carbon atoms. Okay, now here is one question for you. Which of these series can be classified as homologous series? Which of these series can be classified as homologous series? We learned that the homologous series, they will show same functional group and they follow one common general formula. They have same general formula but they only differ in their molecular formula. Now find out the correct answer. Yes, the correct answer is option B. CH3OH, C2H5OH, C3H7OH. Here the functional group is OH or alcohol group, and they have same general formula and they differ by only CH2 group. Next question. A student studies that carbon compounds CH3OH, C2H5OH, C3H7OH and C4H9OH can be grouped as homologous series. Why are these compounds grouped as homologous series? The options are because of an increase in number of carbon atom along the series, because of an increase in number of hydrogen atom along the series, because of the presence of the same functional group substitute for hydrogen in a carbon chain, because of the presence of the same carbon compounds substitute for hydrogen in a carbon chain. Find out the correct answer. Yes, option C is the correct answer. Because of the presence of the same functional group substitute for hydrogen in a carbon chain.